Hello and welcome back to next episode of Compiler Programming. Today I thought I'd switch gears a bit and instead of focusing on the assembly, let's try to clean up our stuff a bit and make it nicer to look at and nicer to write. Because it seems to be that we are accumulating quite a bit of craft and a lot of repetition in different places. So let's deal with that. Also, we might look into making our function stuff a bit nicer to use. So let's just slowly go through the application and see what can we pick up. One thing that is happening, I think, quite a bit is we are creating values from kind of just integers that are given from the main program, like something that you can see here. So let's create a helper function for that and make our lives just a bit nicer. So let's call this returns a value, and we can call it value from S64. And we pass in our S64 integer, and then we just return simply this. Return const value of this stuff. And then integer goes into here. Value from S64, 0. Now we can also take this and say value from S64, 1. And these kind of small cleanups, they are not just important for readability, but also it allows us to make our code more malleable to change, right? Because now it's not going to be such a gigantic task to change maybe how our values are encoded, because there will be less places that are touching them. So that's nice. I think we also do this somewhere in here a few times. And I think another thing that we can do is pre-create these integer descriptors, because they are all over the place and it doesn't seem to be a very nice way to deal with that. So let's do that as well. So we say descriptor integer descriptor integer, and say dot type is this thing, right? Descriptor type integer. Again, this is not really much, but every bit helps. Let's look at where we are using them. We can search for this stuff. Okay. This one, actually, we also should create a helper. Where is my value from S64? And here is our stuff for. So we now create value from S32 and do this, and we can fill this in. Right. That's also nice. Apparently I cannot spell, which is not very nice. But let's continue. Okay, these are our helper functions. It's fine for them to have the descriptor type integer. Here we can just pass a descriptor integer. That's good. Good here. What else can we fix up? We can put it here. Apparently my editor crashed, which does happen. Descriptor type integer. Okay. Ding, ding, ding. Okay, descriptor integer. Don't you like here? Function is not a member. Did I mess something up? Okay, this builds. What about this? Returns descriptor is integer. Oops. That builds. That's fine. Okay. Here we actually can do value from S64. That's good. Let's continue our cleanup session. This seems fine. This seems fine. And we can put a bunch of descriptor integer into here. And ta-da. Good. Now we can also get rid of this one, which is nice. And that's about it for this round. But that's obviously not the end of what I wanted to do. The next thing is I want to focus on this test case. And what we're doing here, just to remind you, is we creating a descriptor for the value that would point to this hello world text. And then we are also creating a wrapper for a puts function provided by C standard library. And it is this wrapper that I want to avoid, right? Because this does not seem to be a very nice to deal with. Ideally, I should be able to say something like wrap C function and or C function wrapper, the function value, and then I should just provide signature, and I will make it such that the last argument is the return value and the first arguments are the actual arguments of this function. So this puts stuff will be a pointer and it will be a pointer to char star, right? So it's this value. This is a bit, as I said, tricky for us right now to do, but we can try. So how such a function might work? Maybe we'll need to have another wrapper here to say that. So what I'm trying to do is I'm trying to avoid this boilerplate, right? And this boilerplate consists of this function definition with a bunch of arguments, and it also has the argument types. So one way we could try to deal with this is by having a function that literally like parses C type definition. Maybe that would be a better approach to do this. So we do void puts, and then it's like this, right? This is what the function is look like. Maybe we'll try to do that. Well, let's just go with this. So let's create this function. Let's helper. So it will accept count char star function declaration, or I don't know, let's call it forward declaration, to make sure that we are like not expecting a body here. And we will need to somehow parse this stuff. I will keep this for reference here, so it is easier for us to understand what we need to do. And how would that change here? I will also take this stuff and say value puts value is so what do you call C function value? C function value of void puts void puts const char star. And right now I will not deal with the names of the arguments, but maybe later we will. So let's just do it the simplest possible version that will work for this stuff. Okay. This is our output. Let's think how we're gonna approach this. So we could always go for like a full-blown parser for this stuff, and I think eventually we will have to do it, because interpretation with C is something very important, and being able to somehow get the function definitions from C headers into this language would be very, very necessary. But for now, maybe that's not exactly the most pressing thing. So how do I want to deal with this? I guess I also don't really use C string functions a lot, to be honest, so I don't even know what is available. I know like I can probably do stir, which should really return to me the position of string in the substring, I guess. Is there like a reference to all string functions? Copy, set, searches for the first occurrence of character C in the string point to do by there. So that seems like what we want. Yep. Well, that will be enough for us, I guess. I assume it returns -1 when it didn't find. Oh no, it actually pointer to the first occurrence. This is not very convenient. What is str return? Is it the same thing? Yeah, it's also the same thing. Okay, I guess we'll have to deal with that. So, what do? We say char star parent is stir char, and we first pass the string and then we pass the character. So we do forward declaration and this, right? So this is opening parenthesis, and before that we assert that we found one. Like for now, our error handling is just assert. Later on, obviously, we'll want something better. So this is our starting of the arguments. Now we want to go back and skip over the name of the function. Or maybe let's just for now do this. Let's do the simplest possible option. And honestly, I also want to get rid of this. So let's start like this. It's not obviously compliant with the how C defines stuff, but right now that's not very important. I'll also get rid of all the white space just to keep us slightly sane. Okay, that's much better. Now, if we do it that way, then we can say that anything before between this parent and the start of the string is our return type, right? So we can say that, how should I do this? The thing about C strings is that they are null-terminated, so once you get into processing of the text, it's a bit annoying. You either have to copy, constantly copy these parts of the strings to do processing, or you have to do kind of your own string type to deal with this stuff. What can we do here? Well, let's even do actually the simpler option for return type. If stir of forward declaration void is forward declaration. Let's have our return value ready for us. So this is going to be a result. Descriptor we can fill in. It's going to be obviously type function, but for the function stuff for now, instead of all of this, we will just fill it in with zeros. And we also, I guess, need to pass the actual function to us. And I think we have this special type. Yeah, function type opaque. Function type opaque function. Okay, and we do this. Okay, that's good. Now we need to do with this, and this is where what I have started to do here. And it's going to be return result. Okay. So the way I'm trying to cheat a bit at parsing this, and honestly we can now even put the name into here, is I'm just gonna do the string comparison check, like does this string essentially start with a particular combination. Obviously there is a lot of combination if you do something like unsigned and const and whatever, but for now this is okay because we'll only have a limited amount of those that we are actually using, so it's okay. And maybe later on we'll change this helper to be proper parser. Okay, if this is void, then we say result descriptor function returns void value. Okay, that's good. Else, let's assert that this is unknown return type. Good. So we have the return type. Now we can do what we try to do here, where we find the opening parenthesis, and then we say paren plus plus. So we kind of, this will point to here when we do this str and now we are pointing to here. And now we have several options. One is to again start supporting better parsing by supporting multiple arguments, but let's start with one argument. So what we are saying is we need to go till the closing brace or till, let's just do better parsing here. It's fine. So we started paren. Now we need to have a loop. For or while so if while we are not at the end of the string, and they say if star char is closing one, then break. If you find a comma, then we assert for now, let's say multiple arguments are not supported, right? Okay, and what else can we find? So we need to split this into tokens essentially, which will be either this char word or the asterisks same pointer, and in theory they can be any amount of stars here. So there's also, I think, could be like this. So I don't know. We will not do the full parsing right now. Let's do simple version. So right now, let me think about this for a bit. I guess if we what shall we do? Okay, I think I know how I want to deal with pointers. So we will just add a variable called pointer depth, and that is gonna track basically how many stars we find. And obviously we will be able to submit in like invalid code in this case, but for now I don't really care that this is the case. So we say pointer depth plus plus. Essentially, if you find a star, say, oh, it's actually a pointer to that thing that you parsed previous, and if you do this, and it's just recursively will continue. And this actually will be quite easy to implement that way. As I said, like we can do this, which is invalid C, but right now it doesn't really matter much. Okay. We could say that, so we need to figure out what is the type here. How can we extract this? And essentially, we can say, so if we found essentially end of the argument, then we'll need to check what was to the left of that argument. But again, we will need to do some memory shuffling if we want to use C functions for this. When I will do parsing for real, we will do our own string type that will have a length and the pointer to the buffer and all the functions available on it, because otherwise it's just gonna be too annoying for my taste. But for now, I guess this is what we will do. So if we how should I do this? So we found an ending thing, this thing, or this thing. We can even combine them. So in any of these cases, what we want to do is try to understand what was the type. For that, we need to store the pointer to where the argument has started to. So we store pointer to here. We now kind of go through this, and let's remove the space for now. We go through this, and then we find, for example, the pointer asterisks. We'll have this boundary and this boundary. We can now start to do this kind of comparison for this stuff. If we take this, extract it, and put it into a new piece of memory that is has correct size and zeroed end. Let's just, I think if I do it, it will be might be easier to understand than me bubbling about that. So char star start is ch. Now we have ch and we have star. So if we say length is ch minus start, we assert that this is not empty, and or actually we don't really assert, because when we get to here, this is exactly going to be the case, right? We parse the asterisk, and then we have the closing brace, and we don't have anything in between. So we say if length, then we need to say char star type is malloc size of no, malloc length plus 1, and plus 1 is for our 0 character end. Then we do memcopy, and I never remember the order of arguments in memcopy. Memcopy copies and characters from source to destination. So first is destination, so we say type ch, or actually start, and then length, and then we say type length is 0. Right, so now we have inside type we should have char, and we can do that again. So we'll later on extract this stuff into a separate routine, but for now we can just hard code this to be what we want and see if our general approach is working at all. So we do a char. Actually we can probably do, we don't need to copy, because we can just do memcompare, right? We know the length of them, and we know that it's yeah, we can do memcompare. Compares the first n bits of memory area. What does it return? Yeah, equals 0. Good, so let's remove this for now. And instead what we are gonna do is we are going to say if, we don't need to malloc this, if mem so it's interesting, right? Because if we use memcompare, then we manually need to check that we don't overrun the size of the string. So we need to say if length, and then obviously this is going to be very inefficient because they'll do a str len every time, but that's fine for now. If a str len of char is the same as length, and mem compare of start and char and str len char is 0, then we found it and we can do stuff. Otherwise we are out of luck and we assert could not parse the declaration or the function signature. Okay, if we did parse it, then this is where things get interesting, right? So actually this should go here, and now we say, so descriptor type or descriptor is, actually this should be star, I believe. Actually no, yeah, we need to create a value star. Arg is malloc size of value, then arg operand is our RCX. We also need to, me should use correct register, or should not use hard-coded register. So basically here we'll need to unify that logic with what we have. Where is it? With this stuff, which is also by itself not fully done. Actually, function argument list. We can clean up later. It's fine. Okay. So wait a second. Argument list is this. Yeah, for now this is fine how we're doing it. But obviously this is not going to survive even until we do 2 arguments. But this is later. Okay, arg operand is RSX, and then descriptor is the interesting part, because here we also have message descriptor, and I think for now I will not do it this way, so this was fine, but this is not what we'll actually use for the function, because in a sense function declaration here does not actually say that it's a fixed size array, right? It's just a pointer. It's a pointer to a U8. And in our case, we don't even have U8, so it will be pointer to an integer, which is something that needs to be fixed as well. Okay, getting back here, we have argument descriptor is descriptor integer, and then what we do is we say that while pointer depth we kind of wrap descriptors into pointers to the previous descriptor, which means that we will need to do some malloc stuff. Let's say descriptor star previous descriptor is malloc size of descriptor. Then we copy paste this and say previous descriptor is arg descriptor, and arg descriptor is this stuff. Right, so as you can see, what we are doing here is no pointer minus minus. So for each star that we will find in the declaration, so we can imagine that there will be like 2 of them. We check, okay, do we have any pointers? Actually, that's not gonna really work for multiple ones. Instead, we need to bring this up. Yeah, actually, this is gonna work slightly differently. Let's take this out of the loop and say that this is like this. So we have an argument, which is some argument. In here, we will assign the descriptor, and instead of increasing this pointer depth, we'll right away do this stuff, so we don't need to have this variable. And we'll move it after here. That sounds reasonable. If you find any of these, we update our descriptor to be the right thing. And then if it actually turned out to be a pointer, then we wrap the descriptor into another level. Okay, that sounds very reasonable to me. But we also forgot to do this. And actually I will take this out of here because we are completely not ready right now for this stuff. Multiple arguments are not supported. Good. This is fine. Value arg. Now we say that result function but it's result. I guess we should do it here for now, yeah. Result function argument list is arg. Here it's actually like this, and here it's also like this. Arg descriptor is this, result function argument list is argument, and result function argument count is 1. And you might be able to guess how it will look like for multiple things. So this will turn into a counter, and for the list we might have to occasionally expand the array and do realloc of it instead of just pointing to a single element. But let's see what the build says, and there is a ton of issues with it. So let's look at this result. It's a result descriptor function. That's correct that you're calling me out on that. Now, what is wrong with the other stuff? Here we need to have semicolons. Previous descriptor is arg descriptor. It's good. We broke this stuff and we need to say puts, right? Okay. This is better. What are you complaining about? Signed, unsigned mismatch. I guess strlen returns unsigned value, so it should be like this. Maybe in64 to S32. Yeah, that's actually very much incorrect. Okay, what else is wrong? Following formal parameter 1 is different from declaration. Yes, indeed it is different. It should be cast to this function. Okay, we have finally built, but the question is, do we run I'm not gonna even attempt to run tests because I'm pretty sure there are a bunch of issues, but maybe let's do it. It's fine. Yeah, it doesn't really work. So this is what I would expect. This is a bit too tricky to get it working in the first go. So let's fire up the debugger and see what is going on. Build tests.exe. Wait for this stuff to start. We also need to open the file and get to our new function. Let's see what's going on. Okay. Source code is different from, is it? Okay, much better. So this is fine. Okay, so we successfully parsed the void value. We can check what ch is. So it found the right place. So we point here. That's good. We have ch. We go in one more. That seems very good. Now we create a value for the argument. It's fine. We go through this. This is not this. Okay. And yes. So would be very helpful if I say actually this should be, let's turn it into a for loop to make it more understandable. And so while star ch plus plus ch, right? This is better. Let's try that again. Right now, this is, we need to rebuild it. Also, we can try to run test. Okay, now we are getting somewhere. So we could not parse the function signature. So it means this stuff did not really work out, but this is something that we can debug, hopefully, rather easily. We can jump directly to here and remove this breakpoint and let it run to there and see what's going on. So ch is star. That's fine, this is what we expect. What is our length? Oops. Length. Length is 4, which seems to be also correct. Now this is going to be a bit tricky to debug. So let's spread it out between multiple values and say S64. Actually, this is U64 of char length is this. Okay. And we can even do very explicit stuff to ease our debug stuff. Same length. And then same memory. Okay. I guess I already see the issue. So yeah, the brace was in the wrong position, and because boolean is actually integer in C, it was perfectly fine that we set like boolean as length of the mem compare. But still, let's finish up the changes that I'm doing, since it reads nicer anyway. Let's check again. It still cannot parse the function signature, so let's check it out. Boom, boom, boom. Can I somehow see the locals? Yes, the locals are here. Length is 4, char length is also 4, so this is fine. If we compare them, so they will be same length. And now we're just comparing start, which is pointing to the right thing, with char and char length. So why is this a problem? Okay, so this is not a problem on the first run. This happens. Yeah. So what I'm forgetting to do is I'm forgetting to update start to ch, because like we have parsed this, now we are here, and it's still not gonna be the right thing, I guess. Hmm. Let me think about this for a bit. So I guess we can move this out here like it was before, or not. No. No. Okay, let's see what the values actually are and what is the condition we need to break on. Blah 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 blah. Update this. And the next run. Length is 1, right? Yeah, length is 1. So we need to do this, I guess. So we are skipping our thing. Let's check this out. And it works. So this is quite neat. So now that all of this means is, at least for this particular function signature, we can very easily take the existing C function, copy paste its type definition, and get our internal value that is very easy to call and does all the right things of passing the registers to the right point. I think off stream what I will do is I will clean this up a bit, so extract this logic into a separate function and expand, obviously, to include like the standard types like int, float, whatever. Actually, probably will not support float for a bit, so it's just going to be int, char, and void among the types that are going to be supported. But I just wanted to show you the idea about having this support. And I believe due to the way we parse stuff, this should also be fine now. So letting the name be there is perfectly okay, right? And as a bonus, maybe before we wrap it up, let's try to put the whole thing of, okay, this is gonna be a const char star, and this will obviously blow up right now because we have no idea what const char is, but we can try to support this. So we say if ch is space, right? It's fine. And like, okay, length, that's good. So what we want to do is now we want to extract this kind of logic of comparing string to the to pointer and length into a separate function. So let's do that. How would we call this? I don't know. C string equal or memory range equal to C string. Maybe something like this. And it returns to us bool. And it will accept char star memory, char star length. Oh, sorry, it's gonna be, I guess, U64 length. And it also gets const char string. Actually, we can do this as void star to be more friendly to the way C does this. And actually, since this is what we are dealing with anyway, we say memory range start and memory range end. We will need to convert them to char stars for the length stuff. Otherwise, we will be kind of calculating in the sizes of void, which is void star, which is size of the full pointer of 64 bits, and we want to calculate the length in bytes. So here we will do some funky stuff of like casting both of the sides to this. Actually, memory range end should go first. Like this, I guess. And I'm never sure about the precedence of this stuff, so it doesn't hurt to have another rep here. Okay, so we calculate length, and then we have the string length of past string, right? And now we can do early returns and say if is not the same as length, string length is not the same as length. I'm not sure if I can do it this way, but let's see. Then return false. And then we also can do like this is not equal 0, or we can now just return this. Okay, That sounds good. Okay. It means now we can replace this stuff here with our comparison. Let's remove the const for now because we did some refactoring and we want to make sure that things don't break for the refactoring itself. So if memory range equal to string, and we say start ch, right? And char. That sounds good. Then we do this. We now cannot really assert on the not matching, but I guess that is fine. I can say, I can do it like this. If start is not ch, then do this. Let's see what is happening. It doesn't know the char length. It's fine because it's now called string length. And then memory range start. Okay, let's check it out. It still works. And now we can actually do our const stuff. And the const stuff will not really do anything. So actually here we should say else assert unsupported argument type. And test, it's fine. But now we can do this. Else if this is const, and we just put here to do saying support const values. Right now I'm not even sure how this is supposed to work in our language, but the point is to not blow up in parsing, because const doesn't actually do anything to the code itself. It's an indicator for the type checking essentially. And in certain cases, if the pointer is actually pointing to the memory that is marked as read-only, it will blow up on runtime, but it doesn't change instructions that are generated in any way. Okay, let's check it out. It still works. And now, so let's recheck that we are building the right thing. Great. So if we look at the function signature of puts, I believe we can parse really the right one. Yeah, so we don't yet support like function arguments, but besides that, it's correct. Actually, puts turns out to be returning an int, which is not what we are saying it returns, but honestly, it also doesn't really matter. This is kind of safe to return void here, because like arrayx is always considered a register that can change at any point in time when you call a function. So even if it puts something in there, we don't particularly care. Like later on, when we do optimizations, we will care that puts has, for example, int as a return value, but for now, it's not important. We could try to fix it up and say, like, add the same stuff here and say, if it's an int, then what it will return is something else, right? So it will do operand. Here it actually is returning, it will be EAX because int is, I believe, 32-bit. And descriptor type is gonna be integer. And this is like this. And we can actually change this to descriptor integer. Since this needs to be a heap allocated value, then we do this. Value star return value is blah blah blah. Actually, we can't do it this way. We need to do it like this. And here we create memory for it. Pressing the wrong button. Control N and Control B are too close to each other, so instead of building, I open a new window. What I wanted to do is try this out and see what's going on. And it still works. Great, we can parse int. But just to make sure that we are running the code, let's do double, and double, as expected, explodes. Great. So I think this is a good time to wrap it up. I think it's nice to once in a while get away from the assembly and do some more high-level stuff. And obviously we are not done with this, but I think it's a nice start and will allow us to much easier start interpreting with C functions. With that, thank you very much for watching and see you next time.